Hi, this is Mr. Sadler coming to you once again live from the internet. If I can get my font here, hopefully I can. This is MCV4U on February the 9th, 2015. I'm actually right down the hall, or I think in the library, so I may try and stop in. I may actually be with you guys as we're watching this right now. Please listen to Michael and the supply teacher today. What's going to happen today is I'm going to go through two limits that I have from a different textbook. Then I am going to give you guys, after that, if Michael wants to go through some of the more difficult limits from the sheet with the class, you can do that. And then finally, you're going to get new homework. That's going to be number 5 to 7 from last week's sheet. Also page 46, number 11 to 13 for those who need more practice. Okay, so what I'm going to do is I'm going to flip to my textbook. Whoops, as you hear noise in the background. I'm going to flip to my textbook. I'm going to pick two limits here at random. Actually, they're not at random at all. They've been carefully selected. And we'll go through this here. Here we go. Limit number 1. So today's limits continue to today's lesson. Example 1. Just give me a second, please, as I hopefully. Oh, great! And my Word has crashed on me. Okay, I'm gonna tell a joke here while this finishes. I'm not sure I don't have any jokes. Oh, there we go. Okay. Okay, example 1. So it's going to say. Maybe it's not. There's my limit statement. Let's try this. Lim as x approaches -6. It says 1/6 plus 1/x all over x plus 6. Okay, and we'll save that for a second here. Copy. Okay, so if you take a look, I'll make it a little bit bigger so you can see what it's supposed to say. The rest of them won't be that big, but I'll make that one a little bit bigger. So that says the limit as x approaches -6 of 1/x plus, 1/6 plus 1/x all over x plus 6. As I mentioned previously, that's what we call an exciting limit. If we do the direct substitution, you get 1/6 plus 1/-6, which should equal 0 over -6 plus 6, that equals 0. Okay, so let's actually solve this one now if we can. Any suggestions? Actually, we won't do that. If I can paste that. Any suggestions on what I can do next? Okay, what I'm going to do actually is I'm going to add the numerators together. So I'm going to write this as, find a common denominator for the numerators. So I'm going to write that as, if I can, x over 6x plus 6 over 6x. I'm going to times the entire thing, brackets here, by 1 over, big brackets, by 1 over x plus 6. Now again, I'm allowed to do that because it's in the denominator. Now what's going to happen here, the dream for this is, since I'm dividing by x plus 6, I'll copy that again in a second. I'll have to make it bigger. You're going to want to get rid of the x plus 6 and get rid of it here now. If you take a look now, this should work out quite nicely. The right hand side is going to change to, hopefully, limit as x goes to -6. The left hand side is going to switch quite nicely to x plus 6 all over 6x all over, and that's times 1 over x plus 6. Alright, by the way, to Michael and the supply teacher, if there are any questions here, You can feel free to hit pause. I'm just going to talk away here because I can't really understand what's happening. Okay, great. Then all the x's plus 6s are conveniently going to cancel. This plus this, we're just going to be left with 1 over 6x. Then we're going to sub-evaluate, and that just equals 1 over negative 36, and all is well. Alright, please be brave and ask questions to Michael. If you need to, there's example 1. Alright, here comes example 2. I may even do it beside. Is that too much math on one page? I don't know if it is or not, but I'm going to try it. Here's example 2. Example 2 is going to be a little bit nicer. Actually, no, it's not. Let me change for last minute. It's going to be the limit. Sorry, give me a second here just to get set up. It's a lot more difficult to do limits on computers than I thought. Limit as x approaches 0 of the square root of x plus 7 minus the square root of 7 minus x all over 2x. I'm going to make this a little bit bigger so we can actually see it. And then I'm actually going to try and solve it. Okay, so this one, when you're looking at it, clearly, whoops, if I can move everything over here, hopefully I can. There we go. Clearly I'm going to have to rationalize this, okay? So what I'm going to do is I'm actually going to multiply it by the same thing top and bottom. What I'm going to do is I'm going to do it on the second line here. I'm going to times it by, where's my time symbol? Where's that one? Let's try that one. Yeah, it's fine. I'm going to times that by the root of x plus 7 and then plus the root of, whoops, oh sugar, 7 minus x. I'll do the same thing top and bottom. Hopefully that one, no, I did. There we go. Okay, so the reason I did that, please note the square roots don't actually change. Okay, right, so this doesn't actually change in there. The only thing that changes is the sign in between the negative changes to a plus. Yeah, we're going to do a difference of squares there. Why does that keep doing that? And oops. We're going to do a difference of squares. The bottom's going to stay the same. I can't change that, but the top is going to change quite nicely. I'll call that 1. Get rid of that. And just call the denominator. Sorry. In my dreams when I was doing this lesson, this worked a lot better. 2x times all that goes in the denominator. And we'll just, whoops. There. And we'll just FOIL with the numerator. This really doesn't work as well as I want it to. Okay, so we FOIL the denominator. You should have had lots of practice with this weekend. That should turn into x plus 7 minus 7 minus x. Okay. So how I got that was root of x plus 7 times root of x plus 7 is x plus 7 plus these two multiplied, then minus these two multiplied, which will cancel, then negative that. It's like a difference of squares. Neatening that out. Hope you can follow a little bit of what's happening here. If not, hopefully Michael will explain it for me when I'm done. That then turns into, the numerator turns into, oh goodness. 7 minus 7 cancels, and we're just left with 2x in the numerator. Now I'm happy because that's going to cancel it with the denominator. Okay. So we're going to end up with limit. This really isn't working the way I want it to. Sorry guys. Hope you can follow what I'm saying. you need to go back and look over this a little bit more slowly, feel free, Michael and the supply teacher, to do so. So what just happened there was the 2x and the 2x cancel, and you're left with 1. Now we're going to evaluate. Oh, no, not. Grr. I'm just going to leave that box maybe. And I'm just going to go over here someplace. And that's just going to equal, I'll hold it, 1 divided by, this is not here. Sorry folks, equals, let's turn to a fraction here, 1 divided by, bracket, square root 7 plus goodness. I know this is hard to believe, but I do actually have a computer science degree, but that's okay. So that turns into the root of, okay, a little bigger so you can actually see it. So once I've, whoa, too big. So once I evaluate, I sub in 0 for x, that's what I get. That just turns into then equals bracket 1 over 2 root 7. And Michael, if you need to explain to the class why that turns into 2 root 7, root 7 plus root 7 is just 2 root 7. Please do not tell me that equals 13.8 or whatever it happens to equal. Please leave please leave everything in square root form. Alright, so that's all I got for today's lesson. Michael, now if you need to go through any of the examples with the class, please feel free. Otherwise, you guys can finish the homework sheet, and then move on to 46 and 11, 13. Alright. Okay, thanks guys, see ya.